Hello friends, today I can see about the BSc 5th SEM unit number 5. The unit number 5 related to the transistor. Now in this chapter you can see the first session, transistor and H parameters. So learning objective of this session is to understand the basics and applications of the transistors. So you can explain here the types of transistors, modes of transistors, and then hybrid parameters, and how to define the H parameters. So you know all the familiar things: current, voltage, input voltage, output voltage, all the things. Now the terms used in this session: transistor. What is transistor? A transistor is the combination of two terms, transfer plus resistor. Transistor is mainly three-terminal device. The two PN junctions formed by sandwiching a P-type or N-type semiconductor between a pair of opposite type. There are basically two types of transistors: unijunction transistor and bijunction or bipolar junction transistor. That is unipolar and bipolar transistors. The bipolar junction transistors are again classified into PNP and NPN transistors. So how these PNP and NPN transistors are constructed, and what are the circuit symbols for this NPN and PNP transistors as shown here. This is a circuit symbol for NPN transistor, and this one is for PNP transistor. So a transistor has three sections. The section 1 is called emitter, then base and collector. The middle portion is called base. It forms two junctions between the emitter and collector. NPN transistor is formed by sandwiching a single P region between two N regions, and in case of a PNP, a single N region is sandwiched between two P-type semiconductor. It has mainly three sections: emitter, base and collector. Emitter is heavily doped, and the function of the emitter is to emit charges. Base is middle region, and its main function is to pass the majority charge carriers from emitter to the collector. And collector is moderately doped, and the function is to collect the charges coming from the emitter and the collector. Now how this transistor works, I'll explain it briefly here. So in order to explain the transistor action, before going to the transistor action, it is important to keep in mind the following facts about the transistor. The transistor has three regions: emitter, base and collector. The base is much thinner than the emitter, while the collector is wider than both emitter and collector. However, for the sake of convenience, the emitter and collector are usually shown to be of equal size. The emitter is heavily doped so that it can eject a large number of charge carriers into the base. The collector is moderately doped, whereas base is lightly doped and very thin, so that less than 5% of charge carriers coming from the emitter can be recombined with base and can pass most of the emitter ejected charges carried to the collector. The transistor has two PN junctions. That means it like two diodes. The junction between emitter and base may be called as emitter base diode or simply emitter diode, and the junction between base and collector may be called collector base diode or simply collector diode. The emitter diode is always forward biased, and the collector diode is always reverse biased. The resistance of emitter diode, that is forward bias, is very small as compared to the reverse bias. Now how this transistor working takes place. The forward bias causes electron in N region. The N type emits to flow towards the base. This constitutes the emitter current. So this constitutes the emitter current. As these electrons flow through P-type base, they tend to combine with holes. As the base is lightly doped and very thin, Therefore, only few electrons, that is less than 5%, combines with holes to constitute the base current. This is a base current. Base current. The remainder, that is 95%, cross over into the collector and it constitutes the collector current. And hence, the total current, that is emitter current, is sum of the base current and collector current. So this is in simple way I explained about the working of the transistor. So according to the transistor can be connected in following three ways. One is common emitter mode, common base mode and common collector mode, depends upon the applications. Among these, C mode is most preferred because a C mode gives highest voltage gain. Now I come to the actual syllabus here, H parameters. So H parameters are nothing but you can call it as hybrid parameters. So every linear circuit having input and output terminals can be analyzed by four parameters called hybrid parameters or H parameters. Out of four parameters, one is measured in ohm, one is mhos and two are dimensionless. These are mixed dimensions called hybrid parameters. The meaning of hybrid parameter is mixed. I have shown you a linear circuit here. So in the first circuit, input voltage and input current as labeled as I1 and V1 here. This is I1 is the input current and V1 is the input voltage. It also has got output voltage and output current. V2 is the output voltage and I2 is the output current. Note that both the input and output current are assumed to flow into the box. Also, input and output voltage is assumed to be positive for the upper to lower terminals. Suppose in a circuit which voltage are of opposite polarity or whose current flows out of box, simply treat these voltage and current as negative quantities. It can be proved by advanced circuit theory that voltage and current in figure 1 can be related by the following equations. So I have given two equations here. V1 is equal to H11 H1 plus H12 V2 and I2 is equal to H21 I1 plus H22 V2. In the equation, H11, H12 and H21, H22 are called H parameters. The following points may be noted about H parameters. Every linear circuit has four H parameters, one having a dimension of ohm, one having mhos and two are dimensionless. The H parameters of a given circuit are constant. If you change circuit, H parameter also change. Now, how to determine these H parameters? In order to determine these four parameters, the first case, short circuit the output voltage. You see here I have shorted here V2, means V2 is equal to 0. Now you substitute V2 in equation 1 and 2, and now by substituting in equation 1 and 2, the equation reduces to H and H11 is equal to, I will take HI is equal to V1 by I1. So HI is called input impedance. So H1 is nothing but HI, I stands for input, and from equation 2 you can write H21 is equal to HF, it is called current gain. So HF is the current gain and that is ratio of output current to the input current, I2 by I1. I2 is the output current and I1 is the input current. So in this way you can calculate first two parameters H11, H21 by short circuit the output voltage V2, that is V2 is reduced to 0. Now in order to determine another two parameters, the second case is input terminals are open, means I1 is equal to 0. So input current is 0. If you make I1 is equal to 0, again by using equation 1 and 2 you can calculate H12. H12 is equal to HR. HR is nothing but reverse voltage gain. So reverse voltage gain is nothing but here it is input voltage by output voltage, and therefore this is also ratio, it has no unit. And from equation 2 we can calculate the output admittance. Output admittance is equal to H22 is equal to H0. H0 is output admittance, and therefore I2 by V2. So ratio of output current to the output voltage that can measure in terms of mhos. So in this way we can simply calculate the 4 parameters H11, H21, H12 and H22. So now next we can see how these can be represented here. H11 is called input resistance when output is shorted. H12 is reverse voltage gain, that is HR, and that can be calculated when input is open. And H21 is called forward current gain when output is shorted, that is it is called HF. And H22 is called H0, and that is called output conductance. So that can be calculated when input is open. Now in order to determine the H parameter in C mode, so in common emitter transistor configuration, the input signal is applied between the base and collector, and knowing that one you can calculate these 4 parameters. So the input voltage, I'll take that as VBE, because your E is common, emitter is common for input as well as output. The input current is treated as here base current, output current is taken as collector current, and output voltage is taken as the voltage across the collector and emitter. By knowing these 2 factors, you can write these 2 equations, that is V1 is equal to, that is V1 is nothing but you can write voltage across base and emitter is equal to HIE into IB plus HRE into VC, where HI is nothing but your input impedance, HR is reverse voltage gain, then HFE is forward current gain, and HOE is output admittance. So that can be explained how to determine again by using the common emitter mode. So in order to calculate that one, again you have to follow the same rules. Now in order to calculate input characteristic, that is reverse voltage gain is equal to what? It is input voltage to the output voltage when input current is kept constant. Now input impedance in order to calculate, that is HIE, that is input voltage to the input current when output voltage is kept constant. So this is same, your whatever you know in case of calculating that V2 is equal to 0 and I1 is equal to 0. By knowing that one you can calculate this HRE and HIE. Output characteristic, how to calculate output characteristic? So in order to calculate output admittance HOE, that is a ratio of output current to the output voltage when base current is kept constant, means your input is 0 here like this. And forward current gain can be calculated as output current to the input current, that is collector current to the base current, keeping output voltage constant. So in this way, here E stands for, it is common emitter mode. Suppose if you take this is for common base mode, this can be written as HRB, HIB, HOB and HFE. Like this, depends upon modes, you can reprint this, the voltage gain, input impedance, output admittance and forward current gain. Now in this way you can calculate the 4 parameters by using common emitter mode. So what you have learned in this session, what do you mean by hybrid parameters, how to determine H parameters, and by using the C configuration how to calculate the H parameters. Okay, thank you.